Because backup power, maybe Amazon's data center gets out of has a blackout for 15 minutes once a year, right? And again, EV batteries or lithium batteries typically have tens of thousands of cycles. So if you're going to only cycle it once a year versus you have so many cycles, it's probably better value for that customer to use the battery for an application that will cycle the battery a lot.
Yeah. So we have to move away from fossil fuels.
Yeah.
We have ambitious targets. I think it's 2050. But there's an abundance of power. The sun, I think what is it on a continuous? It's at 173,000 terawatts, which is more than enough than what we actually consume on a daily basis. And then there's hydro and there's wind. So obviously the problem is capturing that. We need solar panels, but then storing it.
Yeah.
Do you think by 2050 we'd be able to produce and mine enough lithium to be able to build and manufacture enough batteries that there could be a battery pack in every home and every business?
Great question. Yeah. So to address actually the first part, we definitely believe that it takes a village. There's many different types of energy storage as well, right? There's lithium is what we're focused on, but even for us, we do plan on branching out to many different chemistries as well. For example, zinc batteries are popping up, solid state batteries are popping up. You start hearing about air batteries as well, and
graphite.
And yeah, graphite, exactly.
Graphite now,
and we believe that each battery has its own best use case. So for us and lithium batteries, the best use case is what we call a short duration market. So short duration means if you need a lot of power in a short amount of time, lithium is the best by far compared to any other energy storage. It's the best. So typically, what that means is a typical lithium battery can fully discharge, from 100% to 0 in 4 hours, right? That's decently fast in the engineering world. For us at EV batteries, we're aiming for that 1 hour, so we can discharge even faster than traditional lithium that's being used for buildings. Now, but then when you have zinc batteries, they're really great for that 10 to 20 hour application, right? So when you need to slowly discharge over the entire day rather than a short amount of time, and then you have bigger and bigger batteries again, the air-type batteries where they'll discharge over days and whatnot. So we believe that 2050 we can, with a combination of all these different energy storage as possible. One hurdle, though, at least for the lithium side of things, is all the battery material is going into EVs. They're not going into stationary storage.
We need EVs.
Yeah,
the EVs are the priority.
Yeah. So because of that, which is great for the decarbonization of transport, it's not great for now commercial buildings like this are begging for energy storage, right? But then they just can't buy it. So right now there are many companies that have announced the new lithium providers, they buy batteries just directly from China. There's not too much innovation there, and they just make large new lithium energy storage systems. They're sold out for the next 3 years, which is where we're also seeing the opportunity. Where by 2030, it's projected that there's going to be 200 to 300 gigawatt hours of end-of-life EV batteries per year of supply. So now that all of that lithium material and battery material is going to EVs, we can now divert that finally into stationary storage, and then for another 10, 15 years, and then once that reaches end of life, throw that into recycling, and then hopefully that goes back into EVs or any other type of energy storage.
So are batteries the only way to store power? So I have heard some ideas, and I don't know how far-fetched they are. So one is a hydraulic method. So we have 2 pools of water, and of course, when there's excess power, it pumps the water into another pool, and then when you need it, gravity just takes it down and spins the turbines. Yeah. And then there's these big towers, and again, when there's excess power, they raise these huge weights, and of course, when you need it, then you drop the weight. Are these just really far-fetched ideas, or?
So actually, I like both ideas. The gravity-fed ones, essentially the ones with the huge concrete columns, that has a lot of hurdles, mechanical hurdles to that. And there are a lot of more simpler ways to do it, but I'm certain that the engineers and innovators that are working on that have their reasons for why they think that that's the best idea. And one idea for the gravity-fed one is you pick up, when there's a time of excess power, you pick up these concrete columns and you keep stacking them into a tower, right? Or the opposite can happen where there's actually a huge underground tunnel, same with concrete tracks and everything, and you can bring, when there's excess power, you just bring the weights back up, and then when there's power needed, you then let go, and then it'll slowly, due to gravity, drop back down. There are innovators there. I don't know how far they are along there. Seems interesting.
It always sounds good in theory.
Yeah, but the water one, hydro. It's called pumped hydro, and that's actually been in place for a while now. So it's been pretty cool. Like, for example, on Vancouver Island, there's a camp called Strathcona Lodge and Park. I actually used to go there when I was in high school for summer camp too. And I only just realized that they actually had a federal project that had created pump hydro. It was exactly the same thing that what you just said. So they have 2 ponds. Now, there's variability there, though, because they're ponds. So depending on before that summer, when they do use the power, how much rain actually filled up these ponds is actually how much of usable capacity they can transfer from this higher pond. And like you were saying, water, when they need power, water will flow through. There's a little turbine at the bottom, and then it'll power the facility. And then once there's a lot of power and they have solar, they'll pump it back up.